NextJS already does data fetching for us, as well as sending that data to the components. So a good question comes out. Do we actually need a state manager when it comes to NextJS? Hi, I'm Jack Herrington, a principal full stack software engineer. And last week I put out a video on NextJS where we took a look at the different rendering modes of NextJS, which included client-side rendering, server-side rendering, and static-side generation. And a question that I asked from a viewer was, hey, do we need a state manager in that context? And I thought about it, like, you know what? I did a video about 2 months ago comparing 20 different state managers and building up at the end of it an organizational methodology where you could kind of understand the different types of state managers and choose the right one for your application. So what I kind of wanted to do in this video is fuse those two topics together and give you by the end of this a GitHub repository full of examples of different state management methodologies. So what we're going to do is we're going to start off with use state, and then we're going to build on top of that with use context. So basic state, React state management. And then we're going to build on top of that with React query, which is very popular. And then at the end, we're going to take a look at 4 different state management methodologies here. We're going to look at unidirectional state management with Redux. We're going to look at bidirectional state management with Mobx. We're going to look at atomic state management using my favorite, Jotai. And then we're going to look at reactive state management using RxJS. All right, so without further ado, let's go. Okay, so here is the application that we're going to build. It is a single page application, meaning that there's just a single route, and it is server-side rendered. So we have an endpoint that has a list of all the Pokemon. And by default, when the page renders, it's going to give you the first 20 off that list. But then on the client side, we want to be able to do some filtering. So we want to, for example, say bulb and get Bulbasaur. And that means that we have to have all of the data on the client. So we have 2 scenarios here. We have the first SSR render of the 20 Pokemon, and then we have the need to have all of the data client-side local to be able to look at. So how do I know this is the case in this case with this version? Well, if I go over here to view page source, we can see if I do line wrap, we can see that we actually have the first 20 Pokemon all rendered out as HTML tags. And then we have this enormous blob of preload data, and that's all of the data coming from the REST endpoint. Yeah, that's not great, but you just have to do that in this case. The really cool thing is, in this case, we are not actually going back to that REST endpoint. So if I go over here to network, we can see when we render, we literally don't make any fetches off the client after we render. So when I type in over here, bulb, this is all just state that is stored in the app. So this kind of represents the challenge that people have when they think about Next.js and state management, because in our applications, most of what we do is request data from an API and then render it on the page. And if Next.js is doing that work for us, if it's going and getting a lot of that data during server-side rendering or static site generation, then how does a state manager play into that, since that's kind of part of the role and responsibility of a state manager? So that's why we're going to walk through all of the different state management models, and we'll start off with a very simple use state so you can get a sense of exactly how this application works in its most simple form. All right. So the first thing I'm going to do is I'm going to go over to my console, and then I'm going to go into my 2022 directory, and I'm going to make a directory called Next.js state management. And then I'm going to go into that directory. And from there, I'm going to do yarn create and then next app. And we're going to call this first one with use state. So all of these are going to be with something, like with Zustand or with Redux or with use state or with use context. And all of that, of course, is available to you on GitHub for free, linked to in the description down below, so that you can check out the code for yourself and use it as a model in your application if you want to see how to use server-side rendering in conjunction with a state manager in your framework of choice. Okay, let's bring this up in VS Code. Okay, now I'm going to bring up my terminal, and I'm going to go into with use state and then do yarn dev, and I'm going to go localhost 3000. That's going to bring up Next.js. Ta-da! Okay, so now we need to pare this down. So this is our index page. I'm just going to remove most of this. All right, the next thing I'm going to do is convert this to TypeScript. And I'm going to bring in my definition for what a Pokemon looks like. And our service gives back an array of Pokemon. Each one has an ID, a name, and an image. And now I'm going to go and get that from their service by defining a get server-side props, where we fetch from our service and we get back our array of Pokemon. So it's asynchronous. That's why everything is awaited and then asynced. Now, if I click on this, I can show you what the data looks like. It's that simple array of ID, name, and image. And now let's see what we get back by just putting in here Pokemon and then just doing a stringify of our data coming back. And now refresh. So it looks good. Looks like we're making the request all well and good on the server side, and we're getting back that data in the client. So the next thing I want to do is make it pretty. So let's go back over here to our styles, into home. I'm just going to paste in a bunch of styles that we'll use kind of as the foundation of our grid. All right, so now I'm going to go replace all the markup. Come over here, back to my div. Okay, looking pretty good. We got a title of Pokemon, and we're just going to go through all those Pokemon, just take the top 20 and then render out that image. And let's take a look. All right, looks pretty good. We got our 20 Pokemon here, and we can see that we're basically following the model that I showed before. So we're seeing the Pokemon come in as fully rendered and then all of the data for that. So now on the client side, we can do our filtering. So let's go implement that. So the first thing I need to do is define some state for our filter. So I'm going to have a use state in here, and we'll use that to define our filter. Now we'll go and add some markup to actually give us a text box that connects to that filter and then sets the filter when we get a change. So let's take a look at that. Okay, looks pretty good. Of course, it's not actually doing the filter. So what we need to do is now apply that filter to that Pokemon data set. So to do that, I'll use a use memo. Now that use memo is going to depend on both filter and Pokemon. And when either of those changes, it's going to return a new filtered Pokemon, which does our filtering for us. So we'll bring in use memo. And I'll bring in my filtered Pokemon, and that's just going to call use memo. It's going to depend on filter and Pokemon. So when either of those changes, Pokemon's never going to change, but filter will. When filter changes, it's going to then run a filter against that Pokemon. It's going to take each name, make it lowercase, and then see if it includes the filter lowercase. That's going to give us some nice case-insensitive search. And then we'll just take this filtered Pokemon and use it for the output right here. Okay, looks good. And then I'll do bulb again. Beautiful, nice. Okay, all right, let's go back over to our app. And before we go on to the next thing, I'm gonna go see if this needs any kind of TypeScript updates. It probably does, yeah. Okay, so let's add TypeScript and all that. All right, let's run yarn dev. Perfect. Nice. Okay. So now let's try this out with context. Let's imagine that you have a larger app and you want to use this Pokemon data in multiple places and you don't want to prop drill it. So we were going to use native React context to do this. So I'll go and copy this with useState into a new directory called with context. So I'll go back up a directory and now I'll do copy -r with useState and make with context. All right, now I'm going to go into with context and start it up. Okay, looks like we're good. So now what I want to do is create kind of a store. So I'm going to go and take a lot of our code that was in that index and move it into a store. So I'll go down here to with context, go into that pages, index, and then up top here, I'm just going to grab this top stuff. And I'm going to create a new directory called source right at the top here. And in there, a store.ts file. I'm going to just paste that in there. So now we've got our get server-side props extracted, and that's fine. You don't have to have it in that page. This just means that it can be reused in any other page, which is great. But we don't need head and we don't need styles. And the next thing I'm going to do is I'm going to create a custom hook. So we'll call that use Pokemon controller. And it's going to have a lot of the logic from here. So I'll just take that out and paste it into use Pokemon controller. And use Pokemon controller is going to take our list of Pokemon as an input. And then it's going to have a filter and set filter, and it's going to return the filtered Pokemon. So I'm going to return out of here an object, which is going to have the filter, as well as set filter, as well as Pokemon, which will actually be the filtered version of Pokemon. So this is actually going to kind of hide the original data for us, and it's just going to give us back the filtered Pokemon. Okay, so now to share this around as context, we need to be able to create context, right? And also get use context while we're up here. And we'll come back down here and we will create a Pokemon context. So what is going to be in our context? Well, it's going to be the output of our use Pokemon controller. So it's going to have filter and set filter and Pokemon, because those are the things that we want to share around through the context. And it looks like GitHub Copilot has done a really nice job of hinting that. So it's going to be the return type of the type of use Pokemon controller. So we're just going to say, well, we want the type of this guy, and then we want the return type from that, which is going to be this filter, set filter, and Pokemon. Now, of course, we don't have that in there yet. So I'm just going to start off with some empty values. And now I've got our context. So the next thing we need is a provider component, because we want to wrap our application in this Pokemon provider. So I'm going to change this to store.tsx because we're going to define some JSX in here. I'm going to bring in a Pokemon provider, and it's just going to be a React function component. It's going to take Pokemon as well as children, and it's going to wrap the children in a Pokemon context provider, and then use that use Pokemon controller with that Pokemon to give us these values: filter, set filter, and Pokemon. And that's what it's going to disseminate down the tree. And then the last thing we need to do is export a use function. So in this case, it's going to be use Pokemon. And that's just going to use the context from this Pokemon context. So when we call use Pokemon, we're going to get back filter, set filter, and Pokemon, regardless of where we are. All right, so the next thing we want to do is wrap our application in this. So let's go back over to app. And now we're going to bring in our Pokemon provider, and we're going to wrap our component in that. So that's going to wrap every page in our application in a Pokemon provider. Now, one thing's missing from this, though. We don't have the list of Pokemon. So where are we going to get that? Well, we can get that from the page props. So what will happen is this index page is going to go do that get server-side props, and that's going to come in here as page props. So it actually goes to both places. It goes to the page, but it also goes to the underscore app.js, which is a special component that is defined by NextJS, which is basically the app layout. So we're going to put in here Pokemon. And then now we got to go change our index. So let's go back over here to index. And okay, we can take that out. What we need to do is bring in our version of get server-side props from the store. So that is our shared version of get server-side props. So we're just going to export that out of here. That's going to tell NextJS that for this page, we want to use that get server-side props from the store. Now, if you add more pages here, you're going to have every single page in here use this version of get server-side props, because now it's expected over here in my app that every single page is going to have Pokemon in it. All right, so let's save that out. And now in the home here, we will get Pokemon, but we don't need it because now we're going to get it through context. We also don't need this interface over here. What we do need is our custom hook. So I'm going to go and import use Pokemon from the store. And then I'm going to use it down in our home function. So now we're going to get Pokemon filter and set filter from our hook, which is going to be context driven. So I'll take that Pokemon, I'll put it in here for filter Pokemon, hit save, and away we go. Really cool. All right, let's try it out. Bulb. Looks good. Okay, so I know this is a lot of change, but let's kind of go through it both on the server-side rendering side and on the client side. So during server-side render, what's going to happen is we're going to get this server-side props over here. It's going to be using server-side props from here. It's going to do that fetch. That's going to put Pokemon in the page props. Now that's going to go over here to our app as page props with the Pokemon. That's going to then seed this Pokemon provider. That Pokemon provider is then going to call our use Pokemon controller with our list of Pokemon. And that's going to set it in context. It's going to go over here to our use Pokemon controller. Then we're going to go and memoize that with filtered Pokemon, grab essentially list of all the ones that match, which is currently all of them because filter is an empty string and empty string matches is included in every single possible string. So now Pokemon basically just kind of drips through exactly as is. So this is during the server-side render time. And then finally we get back to our index.tsx. We use that use Pokemon to get that list of Pokemon. And that gives us our 20 Pokemon. Then let's see if we actually got that. So we'll go over here to our page, UV page source, and see a line wrap. Yep, looks like we're good. Cool. And of course, we got all the data in the page props. So now the SSR side is fine. We're getting all the data that we expect. Okay. So then during client side time, so I type in bulb there, that is then doing a set filter, which is invoking our use Pokemon controller code. So that's going over here and doing the same thing that we did before. We're just triggering this use memo and then doing that filter and then giving us back our filtered Pokemon. And because we have all of the Pokemon from the page props, we can do the entire list all in one shot. Okay, so let's go on to our third variant, which is React Query. Everybody's really excited about React Query. I am too. I love React Query. So let's go and take our use state example and re-implement it using use query this time and see how that differs. So let's close these out. And again, I'm going to clone this one from use state. So we'll start with use state, and then we'll just say with React Query. But I'm going to make this the simple version, and then we'll get into a more complex version with hydrated state. Okay, looks good. So let's go and add React Query. And now let's see what we've got over here in our React Query simple. So we're kind of back to where we started here. So we've got our get server side props. We got our interfaces and all that. So we're just going to bring in use query. And then I'm going to extract this code into a new function called get Pokemon. And then we're just going to await get Pokemon down here. And the reason I'm doing that is because React Query needs a fetcher. So this is our fetcher for our Pokemon. And we'll rename this to be initial Pokemon, because this is going to seed the initial data of our React query. So now let's do our React query down here. Give the key as Pokemon, and then we'll say that we have got that get Pokemon fetcher. And now we need to use our initial Pokemon. So the way that we do that is we give it an option of initial data and give it our initial Pokemon. So let's hit save. All right, let's fire up our app. Okay, and it looks like we need a query client provider. So let's go over into our app and set that. Go back over here to our app. And I'm going to bring in the query client and query client provider from React Query. Then I'm going to create a query client. And now I'm going to wrap my component in it. Looks good. And I also need to bring in use state. And let's give it a try. All right, looks pretty good. Let's check out the page source. And looks good. Looks like we want. So everything is flowing through on the SSR side. We are getting our 20 with SSR, so we're seeing those tags up there. And then we're also getting the data, and that's the initial Pokemon data. Okay, but there is one little hidden gotcha here. If I go over to my inspector and then I do network, if I hit refresh, we can see that it actually is going off and getting the index.json again. And that's just something that React Query does. There are some options that you can give it to make it stop doing that. So we'll go over here and we'll add on a refetch on mount to say, no, don't do that. And also refetch on window focus, also make that false. Turns out use query is a little bit promiscuous if you don't control it. So let's hit refresh and we'll do again the inspector. And we'll take a look at the network and we can see everything's cool. We're not getting any subsequent requests for index.json. All right, so this is cool, but there's a better way to do this in React Query, and it's around prefetch and hydration. So let's go back and create yet a fourth project, which we will call in this case just React Query because it's not the simplified version that we did here. All right, let me close up some files and we'll get it started. Okay, looks pretty good. So the first thing I want to do is go back over to our index page. And from React Query, I want to bring in dehydrate. And then down in our get server side props, I'm actually going to make that request, but I'm going to do it slightly differently. I'm going to use a query client, and I am going to prefetch the Pokemon query. And that's going to load up this query client with that data prefetched. And then I'm going to, instead of using initial Pokemon like this, I'm going to have the prop be dehydrated state. And then I'm going to dehydrate that query client. I'm going to take all that state that was created from any of the prefetch queries that we did, in this case, just the one from Pokemon, and dehydrate it into some state. All right, so then over here, I don't need to do initial data Pokemon anymore. But there is one more thing I need to change, and that's over on the app side. I need to bring in this hydrate tag and use the dehydrated state from page props. So let's save and try this out, hit refresh. Cool, looks good. I'm going to inspect to see if, are we making any subsequent requests? We are not, that is good. All right, and now I'm going to go and check page source. And there we go, looks good. All right, so I think this is a cleaner model for doing React query in a server-side rendered model. Because take a look. So if I go back over here and I'm looking at get server-side props or doing that prefetch query, we can make as many prefetch queries as we want. That's one cool thing. And that query client goes and stores all of that state for us. And then down here in use query, I don't actually know or care whether it's been prefetched. I'm just saying get Pokemon. And if it's prefetched, it goes off and gets the prefetch data. And if it's not prefetched, it just goes off and gets it right then. Just really nice. Okay, so the next one we're going to look at is Redux. And I'm actually going to bring in a already done version of Redux because honestly, it's a bit too much to go through in one video. All right, so let's go take a look at with Redux. Now, of course, all of this is available to you in that GitHub repo, so you can take a look on your own with this. We have a source directory with a store in it, and that's got all of the Redux stuff. It is in Redux Toolkit, which does make it a bit more concise. So we've got our interface, we've got our Pokemon state. This is the state of the store. It's got the Pokemon, the search string or the filter string. It's got that filtered Pokemon, and then it's got some state, kind of nice, so you can, pending or error state. And then we've got the initial state of the store. So again, all of that just kind of set up. And then we've got our async thunk to go get the Pokemon. That's going to go and do the work. And then down here, we create a slice. Now in Redux land, you can have a store that has multiple slices of data in it. Each one is supposed to have essentially its own semantic boundaries. In this case, I guess it is our Pokemon slice, and that's going to have our initial state, and it's got all the searching and filtering and all that. So let's take a look first at this set search. That's going to set that search value. And then down here in our extra reducers, this is going to be the stuff that monitors that get Pokemon call. So you're going to have your get Pokemon pending, get Pokemon fulfilled, which means the promise has been fulfilled, and we've got our data. So it's going to set the Pokemon in the store to that payload, as well as a filtered Pokemon to that payload. And then anytime we get a set search, that's when we run our search. And then down here, we're going to create our store. And then we're going to start pulling out some stuff from it. For example, the dispatcher, as well as the actions, and then our selectors. So now over here in our page, we get our selectors and we get our set search and all of that. And then we use dispatch and use selector straight out of React Redux. Now, how do we kick this off? So what's going to happen is we're going to do the get server-side props, and it's going to dispatch that get Pokemon async thunk to the store, and it's going to await that. So that's actually going to go do the data. It's going to prep that Redux store in memory on the server. And then it's going to pass as props the initial state of the store to that page component. It's going to do that by viewing this get state. And that's going to have our initial state, which is going to have all our Pokemon in it. But also the Pokemon is going to reside in memory on the server. That's the current state of the model when we do our render. So we're going to come down here. We're going to have our initial state. And then on the server side, we're going to ignore this use effect. Use effects don't run on the server. So it's going to just fly down here and start rendering out those Pokemon. And there you go. So that's how the server side runs. Now, how does the client side run? Well, the client side starts up, it's got its initial state, And now the use effect does run because it's on the client. So then we're going to dispatch our rehydrate action. And that's really the magic sauce here. So let's go back over into the store. And there's one additional method that we have here, or an additional action called rehydrate. And this rehydrate takes all of the Pokemon state that we got from the initial state and then just sets all of the values to whatever we got back in that initial state. And there we go. There's no actual secret sauce when it comes to Redux. There is a Next Redux wrapper, but as I was doing the research for this video, I kind of found that a lot of the examples were sort of behind the times. And honestly, I find this example a bit easier to track. So let's go check it out, see if it works. All right, so here we are in production on this, and let's do our page source. And it looks like we're good. Okay, nice. So if I type in something in here, are we dispatching the right actions to the store? Indeed we are. Okay, so this is a nice kind of walkthrough of Redux. If you are using Redux in NextJS and you're looking for a modern example in NextJS 12.1 that doesn't, in this case, use that Next Redux wrapper, feel free to pull this off the shelf and try it in your own application with your own data and see how you go. All right, so if you're a fan of Redux, you're probably a fan of that unidirectional data flow state management model. Have you looked at Zustand? Let's give it a try. I think it's the unidirectional data model, but it's much more simplified. So let's try it out. So again, I'll shut down our server, and I'm going to go back to use state on this one. So I'm going to start off with use state again, and we'll just use Zustand. All right, now I'm going to go into my with Zustand directory, and I'm going to add Zustand. And let's fire it up. Okay, looks good. Okay, so how do we use Zustand? So we'll go over here to with Zustand, go into our pages on our index page. Again, we're starting off with that use state version. So we'll bring in create from Zustand. What create does is creates a custom hook for you. It's really cool. It's like a unidirectional data flow custom hook. So we'll use create here to create a custom hook. We'll call it Pokemon Store. And what create does, it takes a function that gets given set and get and returns an object. So in this case, we're going to have an array of Pokemon, and we're going to have a setter called set Pokemon, which is just going to set that array of Pokemon. And that's going to be the basics of our store. What we really need to do is we need to type this. So I'm going to use a generic up here. We'll say that we have our list of Pokemon, and then we have our set Pokemon, which is going to take Pokemon return void. Okay, so that's it for the basics of the store, but of course we have filtering. So let's bring in filter Pokemon and filter and set filter. So for filter Pokemon and filter, we'll just start off with an empty array and no filter. And then we just need to implement on set filter down here. So set filter is going to take our filter string. It's going to call state that gets given the current state. And then we're going to set that filter, and we're going to set the filter Pokemon to our Pokemon using the filter that we've all come to know and love. Okay, so now we've got our hook. How do we actually use this? I'm going to do use Pokemon Store. Now down here in get server-side props, what we're going to do is we're going to use Pokemon Store, but we're going to use it a little differently because we're not actually in a React component. We're not in the component context. So what we're going to do is we're just going to say get state. That's going to get the current state of that store. This is something you can call externally to React, which is very cool. And then I'm going to do set Pokemon and just give it our Pokemon. Nice, right? Okay, now I just want to pass the Pokemon through. So I'm going to go over here to our Pokemon. I'm just going to get that from the state.Pokemon. Cool, that's going to have our array of Pokemon. And now we need to start changing out our client. So I'm going to get rid of all of our local state code here. And I'm going to call the use Pokemon store hook that we created. And out of that, I'm going to get all the stuff that we know and need. So we need, let's see, filter and filtered Pokemon and set filter probably. Yeah, that's true. Okay, let's try it out. So let's hit refresh. Ooh, nothing's coming up. Okay, so I think I might know what the issue is. So if I go back over here to set Pokemon, when I set the Pokemon initially, I didn't also set filtered Pokemon. So I need to set filtered Pokemon to that initial Pokemon because, it's basically the unfiltered list. And there we go. Nice. Okay. Very cool. All right. So when it comes to the unidirectional data flow model, I like this a lot. I mean, you basically just go and get a hook. That hook is by its very nature a global state hook, which gives you that global behavior that you're looking for from Redux. But it's so much smaller, so much lighter weight, so easy to control. Zustand, I really like it. Okay, so another popular state management technique is bidirectional data flow, exemplified by Mobx. So let's go take a look at how we do this in Mobx. Okay, let's go take a look over into our Mobx directory. This is gonna be another walkthrough one. So over in store, we now have a source store, and we have a class. We've got a Pokemon store class. It's got the list of Pokemon, it's got the filter string, and it's got a constructor where the Pokemon and the filter are observables, meaning it's a bidirectional data flow. You can set them and you can observe them, and you can get updated whenever they change. Really nice, actually. It's a very kind of fluent, easy way to manage state. Then we got a set Pokemon. This is just going to set that value. You can do this or not. It's basically an action. And then we have a derived value called filter Pokemon. And so this is going to change whenever this Pokemon or this filter changes. It's kind of like that use memo that we were using before, but just a more kind of OO style of this. So we're going to go and create that Pokemon store. That's all we really need to do. And then let's go take a look over in our pages. And in the index, we are going to bring in our store as well as the Pokemon type. And we're also going to bring in observer from Mobx React. So observer is what you wrap your components in to say that they're reactive. Whenever anything that it's looking at changes, then I want to be notified of that. Now on the get server-side props side, all we're going to do is just set that Pokemon value, store.pokemon. And then down here, we'll use that use effect trick again to set the Pokemon. But you'll notice all the way down at the end here, we'll have an observer wrapping around home, meaning that anytime filter changes or filtered Pokemon changes, home is going to automatically update. So let's hit save and try it out. Yeah, looks good. Okay, cool. So interactivity wise, it's great. So how, for example, do we set the filter? Well, this is really cool, right? So all you got to do is just say, hey, the value of filter is just store.filter. And anytime we get a change, we're going to do store.filter equals that target value. Now you can be a bit more structured about this. You can require that certain things are run in actions. You get a bit more strict when it comes to Mobx. It's in a kind of loosey-goosey mode right now. But as you can see, when it comes to compatibility with server-side rendering and of course static site generation, Mobx is just fine. All right, 2 more to go. Thanks for sticking it out. So we've got 2 more to look at. We've got Jotai, which is an example of an atomic state manager, and RxJS, which is an example of an event-based state manager. So let's start off with Jotai first. This is another one we're going to walk through, but it'll be quick, I promise. So again, we'll start off with use state. And into our with Jotai application, I'm going to add Jotai. Okay, looks pretty good. All right, so let's start out with Jotai. Let's go over here in our pages and go to our index. And we're going to bring in from Jotai atom and use atom. Now an atom is a piece of data, a piece of global data. So we're going to create one called Pokemon atom, and it's going to have an array of Pokemon in it. And well, it can be global or it can be local. It's really up to you. But in this case, we're defining it globally, so it's global. And then we're going to bring in a utility function called useHydrateAtoms. And because we have this Pokemon atom down here, we're going to rehydrate that in home with this Pokemon data that we got from our server-side rendered props. So we'll bring this in here and we'll call this initial Pokemon, just to kind of disambiguate it from Pokemon, because then we're going to go and get Pokemon as an atom. And the way that we do that is with useAtom. So we're going to bring that in. And now we've got Pokemon from the Pokemon atom. So let's try this out. Hey, looks pretty good. So let's do bulb. Nice. Okay, cool. Wow, that was fast. Holy moly. Okay, so actually you can do a little bit better when it comes to Jotai. So the really cool thing, the reason I like Jotai and Recoil, which is another atomic data manager, but I prefer Jotai so much, is because you can have atoms actually depend on each other. So this is really cool. So basically when one atom changes, when it's dependent on another, it will change as well. So it's very cool. So we need to create a filter atom, and then we're going to create a filtered Pokemon atom that's going to combine those two atoms and give us back our filtered Pokemon. So first we'll create our filter atom, and that's just going to be a string. And then we're going to have our filtered Pokemon atom, which is an atom where you give it a function. That function has a getter, and then it's going to get that Pokemon atom, and it's going to, which is an array. It's going to then filter it. It's going to get given every Pokemon in there. This is just regular array stuff. And then we're going to take that name and compare it to the current get filter atom, right? So whenever either of these changes, because you're inside this atom and you've defined this getter, it's going to then update that filtered Pokemon. So this is going to give us that connection between the Pokemon, the original Pokemon list, and the filter, and then the filter Pokemon. So cool. Okay, so we need to now set this filter. So let's go down here and we will get filter and set filter from our use atom of the filter atom. And all we need to do, and this is just the coolest thing ever, is just change this Pokemon atom to the filtered Pokemon atom. And then change this filtered Pokemon down here to our Pokemon, hit save, refresh. Oh, that is sweet. Look at that. That is neat. So whenever I type in there, I'm just doing set filter. That's setting this atom thing up here, this filter atom, and then filtered Pokemon, which depends on both the filter atom and the Pokemon atom, is dynamically updating on the fly. This is so neat. I mean, look at the beauty and elegance of this. This is why I really like this atomic model. And in particular, when it comes to Next.js apps, I don't really think that there's a lot of global state that you might need in a lot of cases. And so having the ability to have very granularized global state like this, where you just, okay, if I need it, I get the atom. If I don't need it, I don't. It's okay, whatever, is beautiful. All right, so the last one we're going to look at is RxJS. So let me go bring that in. So let's go look at our RxJS implementation. So what is RxJS? Well, RxJS is an event-driven system. So you create these subjects, well, like atoms in a way, but they are event streams. So in this case, we're going to create a behavior subject. And those behavior subjects, actually in this case, Pokemon and filter, are going to be the rough equivalent of the atoms that we had before. But now, since they're streams, to send data to them, you do this next. So you say the next value of Pokemon is the array that we got back from our service. And then we send off to our application the value, the current value of that stream. So the current value would be the last event data that went into it. In this case, the array of Pokemon. So now that comes into home as our initial Pokemon. And we use our use effect trick. Again, use effect only running ever on the client, to initialize that stream to the Pokemon data on the client. But because we also have it on the server-side render time, it just follows through directly down to here, and you pick up your use memo and you get your filter Pokemon. And then how do we actually look at it? Well, there is a really nice library called observable hooks, and it gives you back a hook called use observable state. And what use observable state does is it looks at any of these streams, in this case, Pokemon or filter or whatever you want to do, and it's going to give you back the state of that. And when it comes to, for example, the filter, all I'm going to do is I'm just going to call next every time I get a new value on that. So I'm going to use the filter value and then filter next, and that's going to give me my interactivity. So let's take a look at that. And I do bulb on this side. Beauteous. Awesome. Okay, so if you're into this eventing model of state management, is certainly a valid way to go. Then you can use RxJS directly, or there are other libraries like Effector and Akita that you can use also in the event-oriented data management space. Okay, so let me give you my 2 cents on what I would use when it comes to state management within Next.js. Honestly, if I could get away with it, I would use nothing. I would go and just take the data from the server-side props and render it. That's, of course, if I don't need any interactivity. If I need interactivity, actually, the first thing I'm going to do is I'm going to go with the use state, use effect, maybe some use context. And then Honestly, because I'm a fan of React Query, I would probably layer React Query on top of that. Certainly if I'm going to be doing any client side data fetching. And then I also get that cool prefetch stuff and everything else. Now, if I do need something more grand, I'm probably going to go, if I'm in a unidirectional data style architecture, I'm going to go with a Zustand, because I think it is a really nice, small, elegant library that does unidirectional really, really well. And if I'm on my own and I just want to try out something really cool, I'm definitely going to go with the atomic model and something like Jotai, because I do think, honestly, when it comes to Next.js apps, the amount of shared data that you have between routes should be fairly minimal. I'm thinking things like the user identity, the jot, maybe the current cart count, the current cart contents. Those are the kind of things to be global. Everything else should be as local as possible to where it's used. All right, well, I hope this is really helpful for you in understanding Next.js and how these state management libraries and approaches relate to Next.js, certainly with its connection with server-side rendering and also static site generation. If you have any questions or comments, be sure to put that in the comments section down below. If you like the video, be sure to hit that like button. If you really like the video, hit the subscribe button and click on that bell, and you'll be notified